This is Algebra 2, Unit 4, Lesson 13 on compound interest. In the world of investment and debt, interest is added onto a principal in what is known as compound interest. The percent rate is typically given on a yearly basis, but could be applied more than once a year. This is known as the compounding frequency. So let's take a look at a typical problem to understand how the compounding frequency changes how interest is applied. Okay, a person invests $500 in an account that earns a nominal yearly interest rate of 4%. So basically they get 4% a year on their account. So how much would this investment be worth in 10 years if the compounding frequency was once per year? Show the calculation you use. Okay, so think about this for a second. You're starting out at $500. All right, if you get 4% per year, it would be 4% added on to what you already have. So that's technically 104%. So that would be 1 plus 0.04, which is 1.04. Okay, and how many times would it compound? It would be 10 times if it's done 10 times overall. Okay, so 500 times 1.04 to the 10. 500 times 1.04 raised to the 10th power is to the nearest cent would be $740.12. Okay, so $740.12. So that's how much would be in your account after 10 years. Okay, now this is when the interest rate is applied once a year for 10 years. If, on the other hand, the interest rate was applied 4 times per year, which is called quarterly compounding, why would it not make sense to multiply by 1.04 each quarter? Well, if this is 4 times per year, it's not 1.04 per each quarter. This is 1.04 per year. Okay, so you would end up with more than 4% a year. Okay, because it would be 4% every time that you compounded. And if 4% per year means it should have been done 4 times. So if you were told that the investment earned 4% per year, how much would you assume was earned per quarter? Okay, so you'd have to take the 4% and it would divide it by 4, so that would be 1% per quarter because it's applied 4 times a year. All right. Okay, so that would be 1% per quarter. So, using your answer from part C, calculate how much the investment is worth after 10 years of quarterly compounding. All right, so instead of 4% per year, it'd be 1% every quarter. So it would be 500, and it would be 1.01, but if it's done 4 times a year, it would be to the 4th power. And so if it was done over 10 years, it would be 4 times a year for 10 years. 4 times 10. Okay, so that's 5 times 1.01 to the 40th. So this is the number of times it's compounded, and it's 1%. So 4 times a year for 10 years. So it would be 5 times 1.01 raised to the 40th power. And, whoops, 500, sorry about that. 500 times 1.01 raised to the 40th power. Okay, so you'd have $744.43. All right, so what you have to be aware of is if you have a yearly interest rate, you have to figure out how many times it's compounded per year and what the rate is per unit that you're looking at. So we changed this one. The 4% was divided into quarters because if it's done over a year, that would be 4 quarters. So the percent would be divided over the quarters. So the pattern is fairly straightforward. For a shorter compounding period, we get to apply the interest rate more often, but at a lower rate, because you have to divide the interest rate over the number of compounding periods. All right, so how much would $1,000 invested at a nominal 2% yearly rate, compounded monthly, be worth in 20 years? Okay, so let's think about this. You're starting with $1,000. Okay, so you would have 100% plus, well, if you're doing 2% per year, that would be 0.02, but if it's yearly but you want to compound it monthly, what would you divide it by? It would be divided by 12. Okay, and how many times are you going to compound it? Well, if it's done monthly, it would be 12 times a year for 20 years. Okay, so this would be 1,000 times 1 plus 0.02 over 12 raised to the 12 times 20 is 240. Okay, so let's put this in our calculator. 1,000 times 1 plus, so we're going to take the 2% divided by 12 times, and then raise to the 240 times that it's going to be applied, because it's every month for 20 years. So you would have $1,491, 0.328 is 33 cents. So it's 1491.33, which would be number 2. Okay, so this pattern is formalized in a classic formula from economics that we look at in the next exercise. You need to know this formula because it's not given to you on the regions. Okay, for investment with the following parameters, write a formula for the amount the investment is worth A after T years. Okay, so A is equal to P, which is the amount we invested, times 1 plus R, which is the rate, yearly rate, divided by the number of compounds. All right, so if it's done monthly, it would be 12. If it's done daily, it would be 365. If it's done quarterly, it would be 4. So semi-annually would be 2. All right, so there's lots of different ones. And the number of compounds per year, the number of times you would multiply it, it would be N times T. So however many times you compound it times T. Okay, because T is the number of years. So P equals 1 plus R divided by N raised to the NT power. Okay, so it's the rate divided by the number of compounds raised to the number of times it's compounded. Okay, so you need to know this formula. All right, so just to remind us what the formula is in the top, A of T is equal to P times 1 plus R divided by N raised to the NT. Okay, so the rate in exercise 1 was referred to as a nominal in name only. It's known as this because you effectively earn more than this rate if the compounding period is more than once per year. Because of this, bankers refer to the effective rate, or the rate you would receive if compounded just once per year. So let's investigate this. An investment with a nominal rate of 5% is compounded at 5 different frequencies, or 5 different ways. Give the effective yearly rate accurate to 2 decimal places for each of the following compounding frequencies and show your calculation. Okay, so if it is a quarterly, how many times a year is that? That's 4 times a year. Okay, so whatever amount that you would have would be 1 plus, which your rate is 0.05, because that's 5%. Quarterly, it's 4 times a year, so we divide it by 4. And then, how many times would it be applied over a year? Well, it would be 4 times in 1 year, so it's 4 times 1. All right, so it would be 1 plus 0.05 divided by 4 to the 4th. If I go to my calculator, it would be 1, oops, let me clear this out, parenthesis, 1 plus 0.05, close your parenthesis, or divided by 4, close your parentheses, raised to the 4th power. All right, so that's 1.05094. So this is 1.05094. So what is, give the effective yearly rate to do 2 decimal places. So this would be the yearly rate right here, because it's 100% over that. So this would be approximately 5.09% interest. that would be your rate quarterly. So that's a little bit more than 5%. Okay, so let's look at monthly. Monthly would be how many times a year? It would be 12 times per year. Okay, so this would be 1 plus 0.05 divided by 12. But I'm going to raise this to the 12th power because I'm doing it 12 times per year for a year, so 12 times 1. Okay, so I'm going to do the same thing, but instead of dividing by 4, I'm going to divide by 12. So this is 1.05 divided by 12 to the 12th. All right, to save myself a little time, I'm just going to go up and grab this, enter, and I'm going to change my 4s to 12. So I'm going to back up here, make this 12. Oops, lost my parentheses when I did that. And then change this to 12. So this is 1.05116. Okay, so this is about a 5.11% rate increase. Okay, all right, let's try the daily. So let's see how we did. All right, so daily would be how many times a year? It would be 365 times per year. Okay, so for the rate part of this, 1 plus 0.05 divided by 365 raised to the 365 times 1 because it's compounded 365 times per year. Okay, so 1 plus 0.05 divided by 365 to the 365. All right, so again, I'm just going to go up here and grab this to save myself some typing. And I'm going to change my 12s to 365. All right, so 365. Oops, forgot my parenthesis. All right, and then change that to 365. All right, so it's 1.05126. So this is actually a change of 5.13%. So you can see that the interest rate is a little bit different over the year because it's the effective rate. What's happening is a little over the 5% because it is compounded at different times per year. Okay, now we could compound at smaller and smaller frequency intervals, eventually compounding all moments of time. In our formula from exercise 3, we would be letting n approach infinity. So you could keep going smaller and smaller and smaller and smaller. Interesting enough, this gives rise to continuous compounding and the use of the natural base e in the famous continuous compound interest formula. This is called the Pert formula. For an initial principal p compounded continuously at a nominal yearly rate of r, the investment will be worth an amount given by a of t equals p to the e raised to the rt. All right, so Pert formula. Continuous compounding is the Pert formula. So a person invests $350 in a bank account that promises a nominal rate of 2% continuously compounded. So it's compounded constantly. All right, so write an equation for this amount the investment worth after t years. Okay, so that would be a of t is equal to p to e to the rt. All right, so your p would be $350. E to the rt, r is the rate, is 0.02, and then t years. So there's your formula. So how much would the investment be worth after 20 years? So a of 20 is equal to p, which is 350. E to the rt would be 0.02 times 20. So you can put this rate in your calculator. 350. Now e to the is the second and the ln key. E to the 0.02 times 20. And it would be $522.14. So that would be your interest. There we go. Okay, so algebraically, determine the time that it will take for the investment to reach 400. We'll save these last two for the next class.